Hello class. This week I'm gonna cover regression and classification. I'm just gonna give you a brief overview of whatever we studied in class. Let's start with regression first. So there is difference between linear regression, logistic regression. Basically understand that there are different types of regression. So first is linear regression. Now, if I just Google this and if I go to images, what I can see is that all of this is a straight line. Look at this. Everything here, straight line, straight line, straight line, straight line. So basically you might have studied equation of line in your algebra or your math classes where you know that y equals to mx plus b, where this m is the slope, b is the y-intercept. That is basically it. We are trying to figure out a line that minimizes the error, basically a line that is in the middle of all of these points, that touches these points such that none of the point is far away. That is linear regression. Now, if there's just x and y, this is called a simple linear regression. But if there is many y's, so simple linear regression is just one x and one y. That's it. Now, if there's multiple, there will be many of these x, like x1, x2, x up to how many, whatever we want, how many we want. All right. Now, one more thing to understand is this equation that you need to learn. This is the equation for your sample squared error. This is what the line minimizes. All right, moving down, this is the equation of multiple linear regression. And there, this is the hypothesis test of this, which you will study in your stats 250 as well as stats 305 if you are a stats minor or a data science major student. I'm not going to go more into it, but if you have any questions, just email me about this kind of stuff. I'll be more than happy to help. I have taken these classes. I have done some of these by myself, so I know how to do these kind of problems. All right. Now, SSE is what we're trying to minimize. If you want, you can learn, but there are two types, L1 and L2 regularization. Basically, these are the ways we figure out what kind of errors to minimize. Now, whenever there is a hypothesis test, there are confidence intervals. All right. So basically, if this is the straight line, this is the upper confidence limit. So we are confident that our line will be in between this, and our prediction is we predict that our whatever value we predict is between these two values. Normally, confidence limit is always lower, prediction limit is higher in general. All right. Okay, some of the more basic stuff. Now, this is the challenge question that he said to do, and I am pretty sure all of you guys in the class did this. Hey, if you want, I think LeetCode has some of the linear regression questions as well if you want to practice more. Alright, now over here we looked at this quadlet. Did you see if there's a straight line it predicted well, but if there's a line like this, it kind of went through it. It didn't capture the entire relationship. Same here, this one value kind of affected all of the data. Same here, there should have been a straight line, but because of this, everything got changed. So what can we figure this out? What lines really base fits? So that is something we need to understand. And linear regression doesn't capture everything. We have to do something called nonlinear regressions. All right. All right. I'm not gonna go through these examples, but okay. One more topic to understand is extrapolation. So our line captures this. All right. This is the relevant range, because our data is trained from x this to x this, so only this range here. We don't know what happens after this, we don't know what happens before this. Maybe this line came like this and went like this. What we are doing is using that linear regression to predict the line. Basically we draw a straight line from negative infinity to infinity, which is wrong, which is called extrapolation. Might be accurate, might not be accurate, we never have an idea. All right. So this is something that we need to keep in mind where we do. Now, one more thing is to understand this r squared. Every regression that you do will have a r squared term, and the way to interpret this is that whatever value you get here, that percentage of the variation in y is explained by x. So if in our case over here, let me take one example. All right, over here our Y, let's say, is gallons consumed, and our insulation is negative 20.04, and our R squared is 95.987. So we could say that 95.9% of variation in gallons consumed can be explained by insulation and temperature. All right. So this percentage of Y can be explained by X. Okay, looking further down, I think the last thing that I need to talk to you guys about regressions is um, these are all kind of similar things, just a bit different. I'm not gonna go into brief because I want to make this video brief as possible. Correlation matrix is something that you need to learn. This is like the graphs. Oh yes, logistic regression. Now, so far we did a straight line, but if we wanted to make a line like this, which kind of looks like, if you are going to read more, I'm sorry, I cannot type better, but it kind of looks like this, a sigmoid function, which is mostly used in machine learning to divide. As you can see in between this line, it acts as a barrier, you know. This, below this is 0, above this is 1, kind of like that. All right. So what does logistic regression do? It uses a function. It might not be the sigmoid function. It uses its own function, which I think it's called logit function, Logit. All right. It does a particular nonlinear transform, which is mostly used for classification. This was the example of linear regression. Now this is an example of logistic. As you can see, this kind of fit in straight line, but this captured a lot more than the previous one. All right. And it kind of mostly works with probability as well. So this is what the logit function is that I talked to you about. There is an equation to that. I don't think it's essential in this case. Now, basically, logistic regression is the regression of log odds. That's it. Now, what is odds? You may ask. Odds is the ratio of probability. I'm sure the professor went more into this in the class, but if you have any questions, just Google it. It's very, I think, let me show you this video. What I was learning, I mostly, let me see, logistic regression stat. So I think the video that I watched was this by StatQuest. About 8 minutes, perfectly explains everything in Zedder. Alright, now we did this. Now what are nonlinear regressions? So there are different types. Gradient descent is one of the examples. But let me see. If there is a function like this, neither linear regression nor logistic regression will be able to capture. So we use something called nonlinear regression that basically uses the function. It tries to get what the function is. It can be like x cubed, x power 4, or how many dimensions we want, and then it kind of fits the model. Now there's two things to remember is underfitting and overfitting, which I'm going to leave you guys to do as homeworks. All right. The next thing that professor taught is classification, which is a based of supervised learning. So we know what the data is. So we know the labels of the model. Classification can be in different ways. Binary is basically true false. Multi-category is basically male female, other genders, stuff like that. Ranking A B C D, non-exclusive categories, whatever we want. All right. Now there are different ways to do these kind of steps. Basically what we could do is we can write a classification algorithm to determine whether a text is hypertext or email or something like that. All right. These are something called, we can do that. All right. Now data types. What kind of data types can be there? It can be a graph, it can be images. Now let's say we're trying to filter out spam. So we'll write a classification model to say if something is a spam or not. We will train it on a large amount of data and we'll see if that is uh, really a spam email or not. Same with digit recognition. We're trying to classify zeros to zeros, one kind of images to ones, something like that. Now what is this? The model will try to predict. Alright, an example application to predict high risk and discriminate them from low risk patients. Yes, we could write this kind of classification algorithms to basically use it in real life hospital scenarios. Alright, some more applications. Alright, let's see what he does. Okay, something that you need to learn is we train a data on the training data. we validate it on a validate data, and then we test on the testing data. And the scores, whatever we want, would be based on this test data, which is this evaluation. All right. And over time, in if you're building something for a business, then you would do this evaluation over and over again on different time frames to see how your model is doing based on time. That would be a time series evaluation. All right. I think in this example, the professor mostly talks about classification, association, kind of things like that, which should be fairly simple for you guys of your, um, since you guys already know the basics of it. But if you are stuck in doing any kind of classifications, I would say start with logistic regression. It's a very good example for classification. Now, one more thing to understand is KNN, which basically predicts the nearest neighbor. This is very useful. I have used this in my recommendation systems. I tried to find out the closest movies, so it's not only for classification. KNN has its own different features as well, but mostly it's used in classification where it kind of does all the things. All right, that should be all. Have a good one, guys.